Hello, and welcome to Astronomy 100. In this particular segment, we're going to continue our discussion of eclipses of the Sun and the Moon. In previous segments, we talked about the overall mechanics of why eclipses occur, and then we talked about solar eclipses and the mechanics of a solar eclipse, as well as one of the variations of solar eclipse. In this particular segment, we're going to shift our focus to lunar eclipses. Eclipses generally fall into two categories, solar eclipses and lunar eclipses. Now, during a lunar eclipse, the situation is very much the same as it is during a solar eclipse. It still involves one object passing in front of another object. And during a solar eclipse, what we have is the moon passing in front of the sun and blocking our view of the sun. And if you remember from previous segments, that it is essentially a series of shadows that fall upon the surface of the Earth, creating the appearance of a solar eclipse. Now, if you'll notice in this particular illustration to the right, what we have here is the Earth casting a shadow. The Earth always casts a shadow. As long as the sunlight is shining on it, the Earth will cast a shadow. And if you recall from a previous segment that the shadow has two parts to it, and we'll talk more about that in just a minute. But in this case, a lunar eclipse involves the moon passing through the shadow of the Earth. And so a lunar eclipse is one that still involves the shadows. In this case, it is when the moon passes through the shadow cast by the Earth. But during a lunar eclipse, this can only occur at full moon, because what we need to have is the Earth between the sun and the moon to create the shadow that the Earth casts and for the moon to pass through that shadow. So lunar eclipses can only occur at full moon, whereas solar eclipses can only occur at new moon. So let's take a closer look at the shadow there. Now, the shadow has two parts to it, just like during a solar eclipse. If you recall, the innermost part of the shadow of any object is called the umbra. And if any object is inside of the umbra, then the view of the sun in this case will be completely blocked by the Earth. So there is no sunlight cast upon any part of any object inside of the umbra. Now, the outermost part of the shadow is called the penumbra, and if you again remember from a previous segment, any object that passes through the penumbra, part of the light from the sun is able to still make it to that object. So part of the sun's surface is blocked, but part of the sun's surface is still visible. So in the case of the moon, as the moon is slowly working through its normal monthly orbit, if the alignment is just right, what's going to happen is the moon will first pass through the penumbral part of the shadow. And you'll notice that when it's outside of the shadow, it is a normal looking full moon. But when the moon starts to pass into the penumbral part of the shadow, it is still a full moon. But you'll notice that the amount of illumination of the full moon is less than it was when the moon was outside of the shadow. So the reason why this is because you still have light falling onto the surface or cast onto the surface of the moon, illuminating the entire surface of the moon. But because part of the sun's light is blocked from view, blocked by the Earth, only part of the sunlight is able to illuminate the moon's surface. So it is a full moon, but it would look a little bit fainter than it does when the moon is not inside of the shadow. Usually, when somebody goes out and witnesses this first part of the lunar eclipse, there's not much to see because the amount of dimming of the moon is so insignificant compared to when the moon is a normal full moon that most people just won't notice it. If you see it side by side, then it's a noticeable dimming of the surface of the moon. But when the moon starts to enter the part of the shadow called the umbra, if you recall, anything inside of the umbra has the complete surface of the sun blocked from view. So there should be no sunlight falling onto the surface of anything inside of the umbra. So it's when the moon starts to pass through the umbra that you're going to start to notice that part of the moon's illumination is going to be cut off. It will sort of look like there's a bite taken out of the moon. And then as the moon continues through its orbital path, it will slowly descend completely into the umbra and becomes dark. And then as it works its way across the umbra, it will reemerge on the other side, starting to become illuminated again because it's in the penumbral part of the shadow. And then the moon will start to work its way a little bit further until it's completely illuminated again, but again, still inside of the penumbral part of the shadow. And then once the moon completely emerges from the penumbral part of the shadow, it will go back to being what looks like a full moon. So the actual moment of full moon occurs right here, but to the human eye, you won't notice the slight differences as we go through this. So that's the general makeup of a lunar eclipse. Now there are variations to this because what can happen is the moon in its orbit can actually pass through the shadow at various different locations. Essentially, the shadow cast by the Earth is a very large shadow compared to the size of the moon. And so the moon can pass through the shadow skimming the top part of the shadow. It could go right through the middle part of the shadow. It could go through the lower portion. And there's variations of all the different ways that the moon can pass through the shadow. So the actual occurrence of a lunar eclipse might be different every time you see it based on how the moon is going to pass through the shadow. So let me go back to this illustration and show you one example of that. You'll notice that if we have the moon in its orbit pass through the shadow up here, then it will pass through the penumbra, never reaching the umbra. And so this type of an eclipse is called a penumbral lunar eclipse. And to be honest with you, these are eclipses that are just not all that exciting because, again, you won't notice much of a variation on the brightness of the moon. These are ones that tend not to be very, very popular. They're ones that the media won't make much to do about because, again, there's not much to see. Another type is if the moon passes through the penumbra and then just grazes part of the umbra, re-emerging into the penumbra and again, then you get an interesting type of lunar eclipse because what you'll essentially have is part of the moon's surface will be dark, but it will shift. That portion will shift as the moon slowly makes its way through the umbra and then re-emerges. So the moon can pass through the two shadows at various different places, creating different types of events and ways to see them differently depending on how this occurs. The last thing I want to show on this particular slide is a lunar eclipse is different from a solar eclipse in another way because during a solar eclipse, only a select few people on the surface of the Earth get to witness the event because the shadow cast by the moon only hits certain parts of the Earth. But during a lunar eclipse, as you can see in this illustration, there is an entire side of the Earth that gets to witness this event. So potentially, we could have billions of people watching this eclipse as it's occurring. And so it's an eclipse event that a lot of people get to see. It's an event that will be very newsworthy because so many different parts of the world are going to be able to see this at the same time. And even though people don't realize it, most people have actually been in the vicinity of a place or have witnessed a lunar eclipse, but maybe they just didn't realize it was happening at the same time. And lunar eclipses actually occur quite frequently because of all the different ways that the moon can pass through the two shadows. So lunar eclipses might occur many times a year. You may have 2 or 3 lunar eclipses in one calendar year, whereas you may only have 1 or 2 solar eclipses in any calendar year. So lunar eclipses are actually more common than solar eclipses. Now what I would like to do is show you an animated sequence of photographs that were taken during a particular lunar eclipse. I'm going to switch to the next slide here. And what you'll notice in this animation that's going to repeat over and over again, what you can see is these are actual individual images of the moon during the entire sequence of events for a lunar eclipse. And what I did was I took all of the individual pictures and I arranged them in a way to keep the shadow, the umbra, if you notice the umbra is right here, to keep the shadow in the same spot. So it creates the effect of making the moon plunge through the shadow as you would actually see it in the sky. Now watch this as it occurs. As the moon passes through the two parts of the shadow, let me remind you again, when the moon is back out here, it's very, very bright, then it becomes very faint, and then it becomes very bright again. But remember, when the moon is out here, it is in the penumbra, and look at how very bright it is. Remember, only part of the surface of the sun is blocked from view. But it's when the moon passes through the umbral part of the shadow that you can easily see more and more of the surface of the moon seemingly disappearing, and of course the moon passes through the umbra and then reemerges on the other side. In this particular sequence, it was not a total lunar eclipse. If you look very carefully, the very bottom edge of the moon stays out of the umbra the entire sequence. So this was still a partial lunar eclipse event. Now, if you look carefully as well, the photographer who took these pictures changed his shutter speed, and that is the reason why when the moon passes through the umbra, you'll notice that it seems to become a little bit brighter again and has a weird color to it. So let me switch to a series of still images that show you this entire event. Do you notice that as the moon is passing through the penumbra, again it is still quite bright, but once the moon passes into the umbra, it becomes fainter, but it doesn't completely disappear from view, and then it reemerges back into the penumbra. So this is a nice sequence of pictures because it shows the umbra quite well. But do you notice how the moon not only becomes fainter, but it is still visible, but it also takes on this red appearance. Now, this is an illusion created by the fact that the light from the sun, although it's completely blocked by the Earth, still passes through the atmosphere of the Earth. So let me combine these two together. This illustration down here is the previous one we saw, and here's the sequence of images. So what we have here is this sequence occurring more or less like this, and that's what this is up here. But do you notice when the moon is in the umbra, it has this still bright but reddish looking look to it, even though the moon should not be receiving any sunlight at all. And the reason why this occurs is when the moon is right here inside of the umbra, there is normally no sunlight that will actually illuminate the moon. But the light from the sun, and the sun is way off in the distance over here, as you can see by the arrow, the light from the sun that just barely skims through the atmosphere of the Earth is going to do two things. The first thing is the light will bend and will actually enter into the umbra when it normally wouldn't if the Earth did not have an atmosphere. The atmospheric effects on light is it bends the path of the light. And the second thing that occurs is when light passes through an atmosphere, the colors of the rainbow get separated out. And what ends up occurring is the light that normally looks rather white has the blues sorted out and the greens and the yellows sorted out, and what's left is red light that primarily survives the passage to the atmosphere and illuminates the moon. So the surface of the moon will still be just barely visible and have a reddish tint to it because of the atmosphere of the Earth. And the ancient people of the Earth obviously didn't know of the physics of this, and they were quite terrified during a lunar eclipse because you can imagine two things are going to be very frightening. First of all, they're expecting it to be a normal full moon that fades from view for a period of time. And the other thing is that the normal looking full moon that has faded has turned sort of this bloody red appearance. And so the ancient cultures of the Earth obviously saw this as a negative, as something very bad. The gods were not happy, and so they always seem to associate these things with something bad. And today we know the mechanics of this. We know what's happening. There's no reason to fear this sort of an event, and it actually makes it quite picturesque if you were to take photographs of this. So essentially we have a lunar eclipse, very similar in the mechanics of what's happening, but what makes it very different is the perspective. On Earth, watching the moon pass through the shadow that the Earth casts is a lunar eclipse. A solar eclipse is when the Earth is now receiving the shadow, and so we see it look differently in the sky, even though mechanically they are the same thing. In a future segment, we're going to talk about why eclipses are rare. Why don't they happen all the time? And we'll kind of tie all this together to show you how we can predict eclipses and know where to be on Earth to be able to witness an eclipse, and how they're very celebrated today instead of feared. So that's about all the time we have for today, and I hope you join me in the next segment.